Hello, everybody, and welcome to Chapter 1, Section 5, Radicals and Rational Exponents. Our essential question is, how can you write and evaluate an nth root of a number? What we're going to learn is how to find nth roots and how to evaluate expressions with rational exponents. So in order to find the nth root, we need to know what it is. So an nth root is written as, this expression here, which has a little n, has a root symbol, and then it has an a, or in this case it's just a representation of a number, where the expression is called a radical and n is the index of the radical, right? So anything that has this root symbol is called a radical, and then the little small number that goes in the corner of the root is called the index of the radical. So it's just something that we should know, is that we can write the nth root as a power. Okay, so we can write, for example, if we have the square root of a, okay, we can rewrite that as a to the power of 1/2. Right, so in the previous section we talked about exponents. So these are the new type of exponents where we can write a radical. So the cube root, the 3 root of a can be written as a to the power of 1/3, as well as a to the nth fourth root of a could be written as a to the power of 1/4, and so on for every other number. All right, so we're going to go ahead and use that same setup. Okay, so I'm going to have my root symbol, I'm going to have my n, and then I have a, right? So this is the nth root of a. So it says we want to find the indicated real nth root of all a's. Okay, so I'm gonna divide this up right here. So that's our form. Now we're gonna go ahead and replace that into our problem here, right? So we have our root symbol. Now in the place of the n for the letter a, so a, this is gonna be a. All right, we're looking for the third root of -27. All right, so what this means is we need to find a number, a term that multiplied by itself 3 times gives us -27. So a root is the opposite of an exponent. Okay, so we're looking for a term, a number that raised to the power of 3 will give us 27. So this is kind of like inverse operations, where we're like when we have multiplication, we need to find something to divide to get rid of something, and when we're looking for adding, we're looking for something to subtract to get rid of. Okay, so what we're doing here is we're trying to figure out in our heads, okay, what number raised to the power of 3. Okay, we're doing this. We're figuring out what number to the power of 3, because we want this to be the same. Okay, what number to the power of 3 will give us 27? Okay, so we can just start with some low numbers. Okay, so I would typically start with numbers from 1 to like 7, and then you keep on going from there. So if I do 1 to the power of 3, that's going to be 1. 1 times 1 times 1. So that's not going to be it. 2 to the power of 3 would be 2 times 2 times 2, which is 8. So that's not it either. And 3 to the power of 3 would be 3 times 3 times 3, which is 27. Okay, so 3 is the number we're looking for to put in here, except we have a negative sign. Okay, so here we need a -27, so that needs to be a -3. All right, so we found the number, we've replaced it, we've substituted our values. Okay, so now this will then, this is just like when adding and subtraction cancel out, multiplying and dividing cancel out. An exponent and an index will always cancel each other out as well. Okay, so all of that will be removed, and our solution is -3. Okay, so the third root of negative 27 is negative 3. Okay, next one we have, okay, setup. We have B, which says we have the 4th, 4 is our index, and then 16 is our A. All right, so what we're doing, we're gonna do the same thing. The faster you kind of learn the better you know your multiplications and your exponent powers, the easier this will become. So 1 is obviously not going to be the answer, so we're going to go ahead and skip through that. Okay, so I'm going to say 2 to the power of 4 and see if that gives me 16. That's 2 times 2 times 2 times 2, 4, 8, 16. Okay, boom. We have to look no further. We know that we have to use 2. Okay, so I'm going to go ahead and do this. We're going to copy the 4 over, and then instead of the 16, I'm going to write 2 to the power of 4, okay, which we know that exponents cancel out with our root index. So then our evaluation of this is going to be just whatever's left over there, which is just a 2. Okay, and that is how you find nth roots. All right, so here are a couple other examples. Okay, A and B I'm going to compare together. So it's actually, I'm going to go ahead and divide this into 4 pieces, and we'll work on them in individual spaces. All right, so I want us to compare this. All right, so here we go. These are very, very similar. We have a third root, we have an 8, and we have a negative sign, okay? But the negative sign kind of applies differently for both of these. For this first one, we're looking for a number that's raised to the power of 3 will give us a negative 8. So we're looking to find something, a negative number, oops, give the answer away, negative number to the power of 3 that's going to give us negative 8. Okay, and that's exactly what negative 2 does, because negative 2 times negative 2 is a positive 4 times negative 2, positive times negative gives us a negative 8. Okay, so here we have negative 2 to the power of 3, and then our nth root and our exponent cancel out, so then our result is negative 2. Okay, now this one is very similar. The only difference is, okay, that this negative sign, because it's outside of the radical, okay, we're already going to carry that down to the answer. Okay, so I'm going to say my answer is going to be negative something. Okay, and just like this one, we know that it's going to be 2 as well. So then we're going to have negative, and then we know that this is going to be 2 to the power of 3. Then our root and our exponent will cancel out, giving us the 2 that's left inside. Okay, so even though our answer here is the same, okay, it's a different way that we approached it. All right, and then this other one's very similar. Okay, I'm gonna go ahead and just do the first one with the setup here. Okay, so I have 16 inside, and I have the, oh, remember, I'm backtracking. I'm going a little too far forward. Okay, so 16 to the power of 1/4. All right, so remember in our first slide when we were talking about radicals, okay, radicals is anything that has a root symbol, can be written as exponents. Okay, so what I'm going to do here is I'm going to transform this, I'm going to change this into a root. Okay, so then the 16 goes inside, and then the bottom number of the fraction is our index. Okay, so that number is going to go here. That's our index. And then the top number is our exponent. So 16 to the power of 1, which is just 16. Okay, so then here, we're going to go ahead and simplify this out. So we're looking for a number raised to the 4th power that gives us 16. Okay, that number is 2. So then our index and our exponent cancel out, so our result is 2. Okay, now this one over here, all right, so the setup is the same. So we're going to take the root, I'm going to put the 16 inside. Actually, it's a negative 16. And we're looking for this number goes there. The bottom one goes in the index. The bottom number is the index. All right. So then we're looking for a number that's raised to the power of 4 gives us a negative 16. Now, initially we would say, well, 2, right? 2 to the power of 4 will give us 16. But we're looking for a negative 16. So then our next possible guess would probably be negative 2. Now, this is also not true because if I do negative 2 times negative 2 times negative 2 times a negative 2, negative times a negative, positive, positive times a negative, negative, and a negative times a negative will give us a final positive. Okay, so it is not possible to get a negative 16 from a 4th power. So this is what we call undefined. Okay, so this problem here is undefined. I can't do it. Okay, undefined means we're not able to solve it because there's nothing for us to there's no way that this can possibly give us an answer. So it's undefined. Okay, and the way we kind of know, so if your number inside the radical is a negative and your index is an even number, it's going to give you undefined. So a negative number and a even index will give you undefined. Okay, so that's something important to keep in mind. All right, so we're going to evaluate an expression with rational exponents. Now, if we notice here, we have a different type of fraction where here we had 1 over 4. Over here we have 3 over 4 and 4 over 3. All right, so we're going to go ahead and show how this is set up. Okay, so first we have 16 to the power of 3 over, and then I'm going to go ahead and do different colors here so we can see where everything kind of goes when we set it up. All right, so this is our expression. So now what we're going to do is we're going to change it into a radical. All right, so the 16, of course, goes into the radical. And then, just like the previous one, the denominator, the bottom number, goes in as our index. So we're going to have the 4th root. And then the top number becomes our exponent to our 16. All right, so we're still doing the same thing here. This is now telling us that we're looking for a number that to the fourth root of 16. We're looking for the fourth root of 16, which means we're looking for a number to the power of 4 that gives us 16. And then once we're done with that, we're going to take it to the power of 3. Okay, so here's what we're going to do to solve this right here. I'm going to go ahead and I know from the previous problem, I know that the fourth root of 16 would give us 2, because 2 to the power of 4 gives me 16. And then I'm going to still keep my 3 right here. All right, so then what happens is the same thing goes. Our index cancels out with this exponent. So then all I'm going to be left with is this 2 to the power of 3. So then I can simplify that to be 2 times 2 times 2, which is 8. Okay, so our answer for this one, 16 to the power of 3/4 is 8. Okay, let's try again with 27 raised to the power of 4/3. All right, so we're going to transform this into a radical. Put the 27 inside. I should have. All right, so again, the bottom number, the denominator, goes as our index, and then the numerator is our exponent. So then we figure out what number raised to the power of 3 gives us 27, and once you figure that out, that should be 3. 3 to the power of 3 is 27, and raised to the power of 4. So what we're doing is we're simply just looking for a way to cancel out our radical. So we're looking for this to be able to cancel it out, because that's the only way we can get rid of our radical, is if we can find a number that simplifies that. So then what we're going to be left off with here is 3 to the power of 4, which is 3 times 3 times 3 times 3, which is 81. So this is the solution, or the simplified version of 27 to the power of 4/3.